So in this video, we're going to be doing some problems related to algebraic manipulation, but it's not going to be, so I recommend you to go watch the previous video if you haven't, because this will make no sense if you don't watch the previous video, because I'll be referring to that video, but also like you can still understand this if you have some good idea of algebra. But so in the last video we talked about we talked about strategic laziness. I keep calling it strategic laziness, but that is what this basically is. We're given a set of identities. We were given a set of identities that linked expressions to each other, so that we can, if we're given the value of two expressions, we can find the value of another expression without even having to find the individual values of those individual variables. So in the last video, we did some example problems that were very straightforward. In this video, we're going to look at some actual algebraic manipulation. So the first problem we're going to do is, given that we have a number m, where m plus 1 over m is equal to 5, then find m minus 1 over m. M minus 1 over m. So again, you can find m. You can find the value of m by quadratically solving this and then just plug it into here. But we don't want to do that, because that is not very elegant. There's a much more elegant way to do this without even having to find the value of m. So, and I'll actually write down the identity that we have to use here. So we know this. And yeah, actually I should have just set you to do the problem without even seeing this expression, but yeah. Now, so I recommend you to pause the video now and just try it on your own, as I've given a very big hint in solving this problem. So the solution is that if we consider m and m1 over m as separate numbers, so m as x and 1 over m as y, then we know the sum of these two numbers, and we want to find the difference between these two numbers. But you'll be like, but we don't, so we're given one expression, the value of one expression, and we want to find the value of another expression, but we're not given another expression that has a given value, so how are we going to do this? We realize that m times 1 over m, so m times 1 over m is equal to 1. So we know the product of these two numbers as well. So we know the sum of those two numbers. Okay, we know the sum of those two numbers. We know the product of those two numbers, as found here. So we can find the difference of these two numbers using this identity. So we can find the difference between these two numbers, m minus 1 over m, straight away. So we can plug these in. So m plus 1 over m. So just rewriting this to make things clearer. So if we just plug them in, and we know m times 1 over m is just 1, so this, and then m plus 1 over m is 25, so 25, the 25 minus m minus 1 over m squared is equal to 4. Is that right? Yeah. And then, so therefore m minus 1 over m squared is equal to 21. So therefore m minus 1 over m is equal to plus minus square root of 21. So there we go. Yeah. So there we go. So yeah, so in this one, we had to find, it was a bit less straightforward, but still the same easy way of algebraically manipulating this, because we weren't given the product directly, but we were given, but in this one, you had to actually use a bit of more problem solving to find that you actually do know the products, though the problem didn't give it to you. So whenever you do math problems, not just for this problem, and this topic, but for all topics and just all math problems, even if the problem doesn't give it to you, you can always find it on your own. So the problem won't give you all the information that you need. Sometimes you have to derive your own information from the stuff you're given, and then things will become easier. So don't always think that everything that the problem gave you is all the information that you have. Derive more information and get all the information that you have, that you can get, and then you'll see something you can do, like in this video, in this problem. Yeah. So now we're going to move on to the next problem, which is quite interesting. Actually, yeah, a bit harder than the other ones, but still pretty straightforward actually. And I'll give you time to do this. So yeah, pause the video and try this problem. So we're given the, oh, okay, I didn't even finish writing the problem. So I recommend you to, oh, okay, so you're looking for x squared plus y squared given the initial conditions. So, not initial conditions, these conditions. So I recommend you now to pause the video and try the problem on your own before I go over the solution. So, you'll be like, what is this expression? What is this expression that I just gave you? Because you can't really, going back to the other video, so actually I recommend you to open my previous video and this video on two separate tabs, and then like have the previous video tab open so that you can see the identities. But also like you should be knowing those identities by heart, so I don't know, it's your choice. But you'll see that there is no identity there that relates this kind of expression. So, but we're going to rewrite this a bit. So we realize that we can factorize this. We can actually factorize this. So this is actually equal to, so if this part, so this is equal to y times x plus y. So we took out the common factor of x times y from this part of the expression. So, and then we have this. But then, oh, so common factor of x plus y, so this is just equal to xy plus 1 equals 45. So that's neat. So we factorized it. And now that we factorized it, we see that we know what x times y is. We know what x times y is. It's 4. So we're just going to plug it into here. So 5 times x plus y is equal to 45. And therefore, x plus y is equal to 9. Which is very neat because, so what we did here is we're given some weird thing, but then we factorized it, and then we use the information that we were given to find the value of another expression, where this expression is much more useful than the value of this expression, because we want to find x squared plus y squared, and we know x times y and we know x plus y, and so we can use this identity to find x squared plus y squared. So x plus y is 9, so this is 81. X squared plus y squared plus 2 times 4, which is 8. So x squared plus y squared is equal to 73. So there we go. So yeah, that went a bit fast, but I'll explain again. So yeah, we found, so if you look at an expression, then you should be able to straight away tell if it's a useful expression or a useless expression. So actually no parts in the math problem, no parts of a math solution are useless, because they each contribute massively to the problem. If we don't have that step, then that proof doesn't exist, that solution doesn't exist. But what I mean by useful and useless means like thinking in the short term. So so this expression it is a symmetric expression, but it's not nice because we don't know many identities that include these kind of expressions. So any expressions where it's the sum of a series of numbers, or the product of a series of numbers, or the sum of the products of certain groups of the numbers, or the products of their or the sum of their squares, or the sum of their cubes, those expressions are useful in the short term. So we're gonna we have to try to get the values of those expressions in algebraic manipulation, because we know a lot of identities that relate them all together. So in this case, we know, I mean, you could have predicted the future of it. You could have gone like, oh, I know x times y, and we want to find x squared plus y squared, so why don't we find x plus y from this using the given information? And then we did, and then yeah. So there are many ways to approach this actually. Like you can think in terms of like trying to find x plus y. You can try to approach it in terms of making this seeing what this actually wants to give us, what the problem is actually telling us to do. So yeah, reading the intention of the problem is very important as well. So yeah, these were problems that were less straightforward than the ones that we did in the previous video. And probably in the next video, we're going to be looking at harder identities. But it will be the same idea. It will be the same idea, just it will be more identities that are relating expressions to other expressions. But here, the highest degree was 2. In other videos, we're going to look at higher degrees, which will be very interesting and very important at the same time. So yeah, I hope you enjoyed this video, and I hope to see you in my other videos.